Hello, and welcome to our webinar. My name is Chris Lunsford, and I have with me Mr. Scott Howe. We are both specialist solutions architects for AWS Outposts. Scott, you want to say hi?
Hello, everyone. Nice to be here.
Today, we are excited to present on architecting solutions for high availability and disaster recovery with AWS Outposts. Now, for more than 15 years, customers have been building internet, enterprise, commercial, and public service applications on the cloud, running their workloads, in the AWS regions. Now, with Outposts, you can now build, manage, and scale on-premises applications using familiar AWS cloud services and tools. And to take those applications into production, you're going to need to architect solutions that meet your application's availability and disaster recovery requirements. Now, to inform you and in your designing and architecting of your HADR architectures, we've published a high availability white paper and a disaster recovery blog post to really let you dive into the details on this subject. Now, these docs, in conjunction with the service docs, will give you all the details that you need to begin deploying production workloads on Outposts. And we'll put the links to these documents in the webinar chat, and we'll post them with the recorded session. And really in the webinar today, we're going to be introducing you to the concepts and the subject matter covered in the docs. And we're going to refer you to the documentation and these resources for the full details. So Scott, should we dive in?
Yeah, I think that's a great idea, Chris. For those who maybe aren't as familiar with Outpost as the two of us, is it worth maybe starting at a foundational level and explaining just specifically what an AWS Outpost is?
Yeah, absolutely. That's probably the best place to start. So what is AWS Outpost? So first and foremost, and to help kind of clarify terms that we'll get into in a minute, AWS Outpost is a fully managed service. And that service provides the same AWS infrastructure, the services that run on top of Outpost, and the tools and APIs that you use in the region to virtually any data center, colocation space, or on-premises facility. And so this is really bringing AWS services into your locations so that you can build those on-premises applications. And customers typically do this for one of a few horizontal use cases. We see customers deploying Outposts to address latency sensitive applications where they have needs for the clients or the resources that are talking to the application to have sub 10 millisecond latency connecting to those apps. They also deploy them when they need local data processing, when they have some internal or external regulations or requirements that require them to process the application's workloads within their facilities, or for the same reason that they need to keep that data within their facilities. So they may have data residency requirements where it says, hey, the storage for this data for these resources, again, needs to stay in your data centers. Another place where we see customers doing this is for kind of complex migrations. You may have applications that have complex interdependencies where one app or service depends on another app or service, perhaps many, and they all kind of get wound together very closely within your on-premises environment. And with AWS Outposts, we let you bring the AWS cloud services into your premises alongside your existing infrastructure so that you can migrate one application or one workload at a time from the infrastructure that you're running it on today to AWS services and kind of unwind those dependencies as you update, migrate, and modernize your applications to run on cloud services. And you do all of that, or Outpost, I guess I should say, enables you to do all of that within your own facilities, so you're not adding latency as you do those migrations. So when you move one service over from your on-premises facility to Outposts, you haven't added any latency in the process, and you can still maintain that high reliability, low latency access between the services so that you don't negatively impact the application's user experience. And so it becomes a staging ground or a two-tiered migration to let you move your apps to AWS services, and then perhaps later on move them from the Outpost to the region.
That's an interesting point you brought up there, Chris. So I know I've worked with many customers that have large-scale ERP systems that multi-petabytes in size. They have a myriad of different integration points, data sources, And lifting all of that and shifting it up to the region is often a very complex engagement. They have to do it all at one time, or they risk potentially introducing latency for certain components that are running on premises still that they haven't been migrated, and workloads that have already gone to the region. And so, to your point, this really enables that kind of model where you can have an extension of an AWS region living in a customer's data center or co-location, controlled by them, but still on the same local area network, allowing them to convert to EC2 or ECS or EKS, or moving to managed database services like RDS, all while maintaining that low latency and not impacting their end users, while modernizing their ERP system. So I think that's a really popular use case that kind of blends low latency and migration into one.
Yeah, absolutely. And you keyed on something important there, which is probably what we should cover next, which is you mentioned extending that those capabilities into their data centers. So let's talk a little bit about the high level concept for how Outposts work and how we can think about this in our heads. So for those of you that have deployed or been deploying applications in the AWS cloud for a while, some of this may be old hat for you. But for those who aren't familiar, let's kind of review some concepts, and we'll talk about what's new with Outposts. So in the AWS cloud, it's composed of multiple regions, and now a region is a geographic place somewhere in the world. So, like for example, the U.S. East 1 region exists in the world in Northern Virginia. And so if you deploy your applications to US East 1, your application is living in the Northern Virginia area. Now, a region is composed of multiple availability zones. Each of those availability zones are distinct, operate with separate control planes and services, so that failure of one availability zone should not affect the availability of the other availability zones in the region. And an availability zone itself is comprised of one or more data centers that provide the services for that availability zone. Now, some customers will think when they first hear about AWS Outposts and how it deploys AWS services into their facilities, that they start out sometimes with perhaps a false notion of, hey, this is going to let me create my own availability zones. When in reality, perhaps the best customer analogy, or the best way to think of the conceptual model to think of Outposts is, imagine taking one or more racks out of one of our availability zones data centers. And so you take those racks out, you roll them onto a truck, and you drive that truck to one of your data centers. And as you're going, you unspool a very long cable from the availability zone data center all the way to your data center. And when you get there, you roll the racks into your data center, you put them into a row alongside your existing infrastructure, and you plug those racks back into the AZ data center with that very long cable, and then you plug them into your local network so that the resources within your data center can speak to the workloads that are running on the Outpost. And this is really probably the best conceptual model for an Outpost. So an Outpost really is a logical pool of compute, storage, and networking capacity. It's using the same AWS infrastructure that we use in our regions. Instead of connecting it back to the region with a very long cable, which would probably be impractical, we actually connect it back via a connection that we call the service link. It's actually a set of encrypted VPN tunnels. And that service link actually terminates in the region, in the what we call anchor availability zone, or the availability zone where that Outpost is plugged back in, on what we call anchor points in the region. And so this allows the Outpost with that local pool of compute, networking, and storage capacity to function as part of your network and part of the availability zone in the region. And so you should think of Outposts as extending an availability zone, not creating a new one. Additionally, the Outpost, to give you that local connection to your network, we have a new VPC construct called the local gateway, and that facilitates the connection to your on-premises data center. That way, you can run your workloads on Outposts using the AWS services that you use through the region. They run locally on the Outpost and can communicate with your resources through the local gateway. And so this is really how you should think about Outposts and kind of introducing some of the terminology that we use.
Chris, I think you probably get this as much as I do, but one of the common questions that I receive is often surrounding how this is a managed service And the assumption is that AWS would therefore be responsible for planning and implementing high availability and disaster recovery for the workloads that reside on the outpost. And it's actually just like it is in region, and the shared responsibility model really dictates that a customer is responsible for their data, and an outpost is very much akin to that in region. So maybe we should spend a moment talking about that shared responsibility model and what the responsibilities of HA and DR consist of.
Yeah, absolutely. And that is really probably the right framework to talk about availability. I know that seems funny. For those of you that are familiar with the shared responsibility model, it's often discussed in the context of security. We will say, for example, that customers are responsible for security in the cloud or the security of their applications and workloads as those applications and workloads run in the cloud. And we would say that AWS is responsible for the security of the cloud, of those services, that hardware infrastructure, of the software and the managed services that we provide. And interestingly, availability and security go hand in hand. Obviously, if your application is insecure, that may affect its availability. If your application is compromised, that can create an adverse reaction for your customer experiences. By the same token, you can say that availability can impact security. If your application is not available and it's providing a critical service, that can adversely affect your business. So availability and security really are a shared responsibility between us, AWS, and you guys as the customer as you deploy Outposts into your facilities. And when you deploy Outposts or the Outpost service into your facility, you take on some extra responsibilities because some things are now out of our control and are now, well, frankly, in your control. Things like physical security and access control. When it's in our data centers, we're responsible for physical security and access control. When it's in your data centers, you're responsible for the attestation to that this infrastructure has been deployed within a secure facility. Same thing. Just think about putting the AWS infrastructure and equipment into your facility. You're responsible for the power, space, and the cooling. So keeping the environment healthy and safe so that the equipment is powered, that it has adequate room, it doesn't overheat, etc. And so those become customer responsibilities just with the nature of the AWS infrastructure running within your facility. And also the network connection. We mentioned that Outposts connect back to their parent region, to their anchor availability zone via that service link. You need to make sure, and because it's plugging into your network and that connection is delivered, like I said, they're encrypted VPN tunnels, because it's delivered over your network. As a customer, you're responsible for providing reliable network connectivity from the Outpost, both to your on-premises network and to give it its connection back to the AWS region. And the last one, which is seems a little odd, but capacity management is probably not something that you think about in the region. In the region, you simply request and spin up a resource when you want it, and the capacity is there. On an Outpost, again, because this is perhaps 1, 2, 3, maybe 96 racks deployed within your facility, it's a finite amount of capacity, and that's something that you as a customer have to plan for, how much compute storage capacity you're going to need within each of your locations.
I think all that makes sense, Chris. If I'm used to managing infrastructure on premises, these are concepts that I'm familiar with, and I'm used to having to plan for different types of failure modes when deploying infrastructure in my own data centers or co-locations. As it pertains to Outposts, what are some common failure modes that customers should be aware of and plan for to avoid having unnecessary downtime?
Yeah, so these are not really anything different, or they're certainly not atypical for failure modes or for things that you need to plan for and think about, just today when you're designing existing on-premises, enterprise IT systems. But you do need to consider these same failure modes and think about them in context of the Outpost service and how how it may impact your service, how it may impact operation of Outposts, or impact your workloads that are running on the Outpost. So let's look at what some of those might be. Again, just typical enterprise IT. You can have network failures. You can have links that go down, service providers that experience disruptions. Outages happen, and you need to make sure that you have thought about what can fail and that you provided suitable alternates. Things like instance failures. Applications can hang, operating systems can crash. you need to make sure that you've designed your application environment resiliency so that it can tolerate an instance failure, that you're not dependent on this instance being up all the time, that you have backups in place. Same thing for server failures. Even the best, highest quality server hardware will fail eventually. And so you need to make sure, again, that if you have, we know that a server can fail, we need to make sure that we plan for a server failure by having alternates available to be able to run our application on. And in addition to these kind of very typical smaller failures that can happen within an IT environment, there's also larger scale failures. So you could experience, a rack or perhaps even an entire data center failure. Maybe it's a power disruption, could be a natural disaster like a flood or a tornado. You need to make sure that you have contingency plans for losing, perhaps large swaths of capacity at either the rack or the data center level. And perhaps thinking even bigger and maybe getting somewhat into the domain that we'll talk about in a little bit of disaster recovery, you could even have larger failure modes, even within the cloud. So you could have failures that could affect the availability of, an availability zone, or perhaps even larger that could affect the availability of a service within a region, or perhaps the whole region. These are all things that you need to think about. And like I said, while they're not necessarily specific to Outpost, these are common things that do happen. We like to think, we've got a quote up here on the top right-hand side from Werner Vogel's, failures are a given and everything will eventually fail over time. And so with that concept, we need to design and build our systems such that we embrace failure as a natural occurrence and that we have plans and dedicated mechanisms for mitigating those risks.
I think these modes make sense to most individuals. The one that resonates the most to me is that disparate paths back to the region. At my previous employer, it seemed like at least once a year, we would have an overzealous backhoe driver that was doing construction somewhere on the grounds that would take out the WAN connectivity, and it would never fail. It was like clockwork, at least once a calendar year that this would occur. And so we were really vigilant about ensuring that we had redundant, separate, disparate links out of the campus to ensure that if that ever happened, when it happened, that we weren't going to impact the entire client base and have unexpected downtime. So it's really not any different than commodity infrastructure from that perspective. Or if you have deployments on premises and in the region now, ensuring that you have redundant paths to gain access to that infrastructure, it's really no different than that, wouldn't you say?
No, absolutely. I mean, with each one of these failure modes, and we're going to talk some more about this as we go through the session. And again, we're going to invite you to dive into the details in the paper and the blog post that we mentioned at the start of the webinar. But, for each one of these failures, I mean, if you're considering that network failure path, like Scott's talking about, where somebody's taking out a backhoe, taking out some fiber with a backhoe, this is kind of a regular thing that happens in the world, right? Is with each one of those potential failures, again, you want to make sure that you have a backup and that you've got either an automated or sometimes a manual mechanism to be able to switch over to that backup. So for example, if we lose this network path, we want to make sure that we have an alternate path that can provide that connectivity. That way, when the failure does occur, and hopefully this network failure, we're using dynamic routing and it just heals on its own. That way it doesn't impact our availability and the applications, whether they're running in the region, in our availability zones, or whether they're running on our outpost, that they remain available. And you have options, and we're going to dive into some of these, but you have options for each one of these failure modes to mitigate them and to make sure that you can tolerate the loss of network links, of instance failures, server failures, et cetera. And so we'll dive into some of those details, Scott.
Customers may not be aware of the mechanisms that are built into AWS Outpost as a service that don't necessarily require additional architecture to implement that could enhance some of these capabilities and create additional resiliency. So why don't we spend a couple of minutes first talking about the built-in kind of table stakes options available to customers that can help in this?
Yeah, so just inherent in the Outpost architecture, as you said, Scott, there are several items that improve the Outpost availability. And frankly, that takes some of that planning and some of that responsibility off of your plate and puts it on ours as part of those managed services. So just for example, things that are done included, that are built in right there for you today. Things like redundant power supplies. We're not going to ship Outposts without redundant power supplies. And so that's taken care of for you. Again, this is a service and you don't have to think about that aspect. Same thing actually as it relates to services operating within the Outpost. It comes with fully managed networking services within the confines of the Outpost racks. That's our responsibility, and we take care of that for you. In fact, it provides the same VPC networking that you all are familiar with today. When you want to run, or utilize networking services on Outpost, you go to the AWS console, you create a subnet, you use the tools and interfaces that you're familiar with, and we take care of the redundancy and availability and implementation, within the Outpost rack. Same thing for the storage services. The storage services are fully managed. We'll talk a little bit more about those, but that's something that we'll get some input from you, and then we will take care of that availability. And then there are some things where it requires either some input from you, or it requires you implementing a mechanism on your side to improve the availability. So things like, for example, the redundant power feeds. We highly encourage you to request your Outpost with redundant power feeds and to plug those in to diverse power paths. That way, if you lose a power source, again, the Outpost continues to operate and function, and you don't have disruption to your applications and workloads. By the same token, the compute services on Outpost, this is EC2 compute, as we also support container services like ECS and EKS. So fully managed compute services available on the Outpost. But one part where we need input from you, or part of the customer responsibility, is capacity management. We need you to tell us, here's how much capacity I need, both for my apps and spare for availability purposes. And we'll talk a little bit more about that too in a minute. And as well as mechanisms that you need to enable. Every Outpost comes with redundant fiber connections. So every rack, we're going to hand you 2 fiber connections, at least 2. It could be more than 2 if you need multiple links for bandwidth, but we're going to hand you at least a pair of them. And you certainly could plug those into the same network, switch, I should say, and it would function. But if you lose that switch, it's going to impact your availability. So it's one of those where you need to take some diligence and to employ the mechanisms that we provide so that you can get all the availability benefits out of the Outpost that it can provide.
I think to that point, Chris, depending on a customer's workload, if this rack is earmarked entirely for development and non-production testing workloads, they may look at it and say, a single customer device that the 2 Outpost networking devices connects to is a reasonable risk for them, and they may not feel the need to have redundant customer devices. But for production workloads, it's always the best practice that you have that redundancy there. And ensure that in the event that, who knows, there's mutant cockroaches that chew through the fiber, or somebody unplugs a customer device, you still have another path because they're set up in such a way that they're active.
Yeah, absolutely. And so it really is for you as the customer, as the architect that's designing these solutions, it is up to you to choose and to work with your developers and your business team to decide what amount of availability is needful for that workload. If it's dev test, as Scott said, that might be a little lower. And if it's production applications that your business is relying on, the more you're going to want to employ these mechanisms to ensure that you're providing a highly available environment.
Are there any potential best practices that you would persuade a customer to consider when we go a little bit deeper into the networking side?
Absolutely. There are tons of best practices that we would recommend. In fact, again, we're going to plug you, another plug for the paper and the blog post that we're directing you to is go dive in, because there's lots of details. As a matter of fact, what I have on the screen here, network resiliency, we're going to introduce the topics. We've got one slide to introduce these here, but I think it's like 10 pages in the paper. So dive in and go check it out. But just to introduce the concepts, absolutely. We talked briefly about network attachment, the fact that we hand off from every Outpost rack, those redundant fiber connections. As I mentioned, you could plug them into a single switch, and that decision might be okay for dev test, but certainly if it's production, probably not a good idea, because if that switch fails, it's going to affect your availability. So we provide you a mechanism with those redundant connections to where you can plug those into redundant network devices in your network. And those network devices can be hopefully fully meshed to the rest of your network, so that network attachment where it plugs into your network doesn't become a single point of failure. And we give you the mechanisms and how we do those links, how they plug in, both the layer 2 Ethernet links, as well as the layer 3 mechanisms of IP and BGP that run over those links. We provide you what you need to set that up as a highly available network attachment. And we encourage you to use those mechanisms so that, again, that place where we plug in doesn't become a bottleneck of availability and impact your users' experiences. So we absolutely recommend redundant network attachment. We talked about that service link connection and how the Outpost connects back to its parent region and its anchor availability zone using those Outpost anchor points. So with that, we highly recommend that you provide redundant paths from the Outpost back to those anchor points. Outpost is a fully managed service from the region. We talked about how it's an extension of an availability zone, and it really depends on being connected to that, so that when you make API calls to say, hey, deploy these instances, or perhaps you're requesting telemetry, from your ALB resources that are running on it, all of that has to happen with the communication from the Outpost to the region. And so those anchor connections, that service link connection needs to be available. And so we recommend that you have redundant paths. Again, another solid recommendation that we hope everyone will do for their production applications. Lastly, this one probably goes without saying, but it is worthwhile. At the end of the day, you're not deploying Outposts just because they are awesome, which they are, but you're deploying Outposts so that they can serve your clients and applications. So between the Outpost and your clients and applications in your on-premises network or within your enterprise IT environment, again, make sure that you have those redundant paths available there too. That way, some network partition or network outage isn't going to impact the utility of the application. You want to make sure that your clients in your on-premises applications can connect to the workloads on the Outpost.
So I'll add, when we're talking about this center anchor connectivity option for the service link on the WAN, it's relevant to understand that we support both direct connect as well as commodity internet paths to provide that connection back to the region. And some customers may want to consider doing direct connect as the primary and a secondary direct connect as the secondary to provide that kind of redundant pathing. But they also have the option, if they're doing public connectivity, to do direct connect as the primary and commodity internet as a secondary path. And so there's it doesn't always have to be the most expensive option to provide that resiliency. There are options that are supported to provide different mechanisms there.
Yes, yeah. So Direct Connect is a great option that can give you, finer control over your latency between the Outpost and the region, as well as the bandwidth availability potentially between the Outpost and the region. And as you said, it can also be via commodity internet, where latency and bandwidth availability can fluctuate, but nonetheless the service may be less expensive. So at the end of the day, the requirement is to keep the Outpost connected. How you provide that connectivity, be that via direct connect or via commodity internet, both of those are viable options, and we support those.
Yeah, that makes sense. So we've covered networking. You also mentioned compute and capacity planning as a potential failure mode. Why don't we spend a minute talking about those considerations?
Yeah, so it's kind of funny. It feels like talking about capacity planning within a high availability conversation, but it really does have some impact. So let's talk a little bit about that. So there's first of all an obvious impact. If you have utilized all of your capacity and you go to request that next instance that you need, of course it will fail. The system will return an insufficient capacity error. It'll say you can't deploy this, you're out of capacity. So there's both a consideration from, hey, as you continue to spin up new workloads, making sure you can spin them up when you need them. And that can also impact your availability if some of your workloads are elastic and they need to scale up. And they go to scale up and perhaps there aren't resources available. So both for provisioning new resources and for elastic workloads, you need to make sure that you have sufficient capacity for your application needs. Otherwise, of course, it can affect your availability. Now, when you're doing this, and this is where things get a little interesting, things you don't have to think about in region, but that you definitely need to consider on an Outpost, is that you need to consider all of your workloads, all the workloads that are running on the Outpost. And when I say all, it's things that, in the region you don't think about. Services like, for example, the application load balancer. In the region, if you go and spin up an application load balancer, first of all, it's a few clicks or a couple API calls, and you have a load balancer ready to use. And the same is true on Outpost. So you go to spin it up, a couple clicks, a couple API calls, and you have a load balancer ready to use. What you don't see in the region is the way that the application load balancers are consumed in the region. The way we bill for them is, you spin up a resource, you get charged for that resource, and we charge you for what are called load balancer capacity units in the region. We say, hey, application load balancer scale elastically. As it scales up and it's consuming more resources, we simply charge you for those resources through LCUs. But in the region, you never see that application load balancer is actually running on EC2 instances. It's actually spinning up sets of EC2 instances, starting with smaller sizes, starting with large instance sizes, and scaling up from there, and then scaling out as needed to handle the load placed on it by your application. But on Outposts, you do see that. So as you spin up those ALB resources, and as they scale elastically to accommodate the load placed on them, they actually consume EC2 instances. And so a lot of times our customers, as they're thinking about, hey, how much Outpost capacity do I need? They're used to thinking about workloads like, oh, I'm going to spin up these EC2 instances. Let me make sure I've accounted for those. They may even say, hey, I'm going to spin up these EKS nodes, these RDS instances. And sometimes they forget resources that in the region are just managed services like ALB, but on Outposts are also going to consume some of the Outpost capacity. So as you're doing your capacity planning, the note here is to plan for all of your workloads and really look at it. Every resource that's going to deploy on the Outpost is going to consume some capacity. Make sure you know what it's consuming and that you plan for that. And in that planning, ensure that you're planning for peaks. If they scale elastically like ALB does, or if you're using EC2 auto scaling groups, plan for that peak utilization to make sure that you're going to have the resources that you need. In addition to planning for growth, today, if you size your Outpost for exactly what it needs today and the workloads that are going to be on it, that's great. And if those are all the resources that are ever going to run on it, that's great. But if it's not, then you probably want to factor in, some growth factor and say, hey, I plan to grow 20% or 30% in the next 6 months. Let me go ahead and pre-provision that capacity. And same thing, again, from an availability perspective, considering things like server failures, we talked about that earlier as one of the failure domains, is, hey, if one of these, C5 servers fails, you want to make sure that you have a backup. In the diagram here, we show I have 2 of those servers, and if one of those fails, as long as the full needs of my application workloads can be served by that other server, then I'm in good shape. And we would call that N+1 redundancy, or N being how much capacity I need. In this case, 1 C5 server, and then I have what I need plus 1. That's that extra C5 server. That way, if one of them fails, I still have what I need. And when a server fails, we typically replace those. It's a managed service. We do monitor them. We'll detect the failure. We will schedule to come out and replace that server for you. Typically takes about a couple of days. And when we do that, you may be down that available capacity. You may have just what you need for that period of time. And if you want to be doubly sure, or if your availability requirements require it, and say, hey, even when we have a server down and it's being replaced by AWS, I want to make sure that I still have a backup. You might want N+2 or higher availability. Again, that's up to you to confirm. And just the last note on capacity planning, Scott, or at least for me, you may have some notes on these, but is planning for each instance family. We show on the left-hand side some of the instances. There are actually others that are available too, for example, C5D instances, et cetera. But you need to consider availability for each one of these instance families. So if you have a mixture of servers in your Outpost environment, you have some C5 capacity, some M5, some R5 capacity, you need to plan for each of those independently. And you're going to want to monitor that utilization. As you deploy your Outpost, once it's put in place, you want to monitor it to make sure that your spare capacity stays spare and that your growth doesn't grow into your spare capacity, leaving you in a bad situation if a server fails and you don't have the spare capacity you need to spin your workloads back up.
The only thing I'll add, Chris, is on that topic of monitoring, and you've touched on it a little bit as we've gone throughout these slides, but there was a deliberate design decision, an engineering choice to make this an extension of our region as opposed to offering a local control plane. And the value is that a customer can log into the console and manage resources that are deployed in an availability zone. They can deploy it to a local zone or a wavelength zone, or even on an outpost that would be residing in their data center, and use monitoring tools in that single pane of glass to monitor the capacity regardless of where those resources are. And that's a huge value and benefit to this consolidated view. You don't have to use different tools and different ways of approaching that capacity management because of the way that we extend the region.
Yes, absolutely, and that's perhaps one of the greatest advantages of Outpost is single interface. We call it a consistent hybrid experience because you're using the same services that you use in the region. They're just deploying locally into your data center, running on top of AWS Outpost. As a matter of fact, a good example of that is probably a feature we just announced. This has been in region for a while. We had placement groups in the region, right? And if you wanted to make sure, for availability purposes, that saying, hey, when I spin up an instance or a pair of instances in the region, I want to make sure those aren't running on the same server. Heck, I may want to make sure they don't run within the same rack. And so we recently announced support for placement groups on Outposts. So if you have 2 or 3 or more racks in your Outpost, and you want to use placement groups, you can now do that. And you can say, hey, when I spin up these related resources, it could be front-end web servers. When you spin those up and you want to make sure that, hey, I'm distributing those across my Outpost infrastructure so that a server failure or rack failure doesn't impact it, you can do that. And so from a capacity planning perspective, you might actually even want to think, hey, instead of putting all of this capacity in a single rack, it may fit in a single rack. But instead of doing that, I might actually want to consider splitting out some of that capacity into a second rack, just so that I can take advantage, Scott, as you mentioned, of some of those native AWS service features like spread placement that can distribute those instances across the racks in your Outpost. So absolutely, that's some of the big gains, is saying, let me use the services I'm familiar with to build the apps in my on-premises data center.
I think you'd agree there's a lot to consider with compute. There's quite a few different aspects of peak and growth and workloads, of which the document that you wrote, that white paper, goes into a lot more detail than what we're going to be able to cover today. But storage tends to be a little bit simpler. So why don't we spend just a moment talking about how they might approach storage resiliency?
Yes, absolutely. And this is another area where Outpost shines, right? So from a storage resiliency perspective and from a capacity planning perspective, it is much simpler. So, the storage services on Outpost are fully managed services. So we have S3 and we have EBS. And the nice thing about this is we really just need a couple of inputs from you. We just need to know, hey, how much block storage do you need, in your environment? So as you're inventorying your workloads and you're taking a look at them, saying, hey, how much do I need for my instance root volumes? How much do I need for my additional attached volumes? Again, consider all the services that are going to run on it. Things like EKS, ECS worker nodes, RDS instances, Elasticache instances, even ALB. We called that out earlier, how it consumes EC2. It consumes some storage. So as you inventory your workloads, the only real information we're going to need from a customer when you go to place your order is, how much EBS storage do you need? And then beyond that, we take care of the availability within the rack. And so you don't have to worry about managing those storage servers or any of the backend application. You just consume EBS volumes, like you do in the region today. Same thing actually with S3. We're going to ask you how much, object storage do you need for both for your applications and supporting your applications object storage, as well as for EBS snapshots. So if you want to do local EBS snapshots, Scott will talk a little bit more about this in a minute. But if you want to do local EBS snapshots, you can store those on S3 on the Outpost. And so we'll just need to know from you how much EBS storage, how much S3 storage do you want? And then we go off to work and we manage the availability within the Outpost. Now, Scott, it's interesting though. So a lot easier from an availability perspective. You just tell us the quantity and we will provision it and maintain the availability within the Outpost. Again, you're going to want to monitor it to make sure if you told us 11 terabytes of EBS that you don't go try and request that 11 terabyte and 1 byte and get an insufficient capacity error. So you do want to monitor it. But it's interesting, Scott, that this is one of those things where you're really getting the blessing and the benefit of Outposts. Especially for data residency customers or customers with local data processing use cases, where they say, hey, I need to keep this data within my facility. The nice thing is with EBS and S3 on Outposts, you have it. It is there. It's in those Outpost racks that sit within your facility. But that also leads to a challenge or something we need to think about when it comes to data persistence, data protection, and disaster recovery, which is, hey, it's great that my data now lives in this rack or these set of racks. But what do I do if something happens to that rack or those set of racks? So, Scott, how would you improve resiliency, for an Outpost to protect against those larger failures?
If you think about it, Chris, this isn't really dramatically different than the way a customer would deploy something into a region or availability zone. I mean, the storage, for example, that you just covered is equivalent to GP2 in region. For durability needs that exceed what GP2 can provide, a customer still needs to consider how they might ensure that if an availability zone suddenly were to ever disappear, that data would still continue to be accessible and consistent. So from that perspective, this is no different. Now, customers have several options. We've talked about networking and compute and storage. Those are really the three main types of resources that need to be focused on. And if we consider the network connectivity back to the region, customers certainly have the flexibility to deploy more than one outpost that are anchored to different availability zones. We have here as a diagram Outpost A anchored to availability zone 1 and Outpost B anchored to availability zone 2. to in the same region. And depending on the workload and the architecture, that may make complete sense, but there's still a reliance on that region. So if that region were to ever to be offline for an extended period of time, both outposts would no longer be able to be managed from that console. Now, otherwise, you could deploy Outpost C, for example, and anchor that to a completely different region and its associated availability zones. So this kind of resiliency would allow you to potentially take data and replicate it or ensure workloads are spread amongst multiple availability zones, multiple outposts, ensuring the greatest amount of flexibility. Now the options that exist here are going to be outpost to region, of course, outpost to outpost, and in some really unique situations, even region to outpost. Chris, have you encountered any situations where a region to outpost model might make sense?
Well, I've encountered at least one at a customer in Canada. We have a single region in Canada, and they had some data residency requirements they needed to comply with, which said that they would keep this data in region, but they also needed it to be further away from where that region was centered in Canada and have it placed elsewhere. And so they were looking at using Outposts as this kind of region to outpost backup situation to be able to meet their data residency requirements. In this case, they're going to run their application primarily in the region, but then place the outpost some distance away within Canada so that they could comply with the regulations and still have improved data persistence, protecting their data that's stored in the region.
I think once we start considering that kind of a deployment model, we're really moving away from HA and more towards disaster recovery. So it's worth maybe spending just a couple of minutes talking about what's integral, what's built in to AWS Outpost as a service, similar to the way that we talked about what was built in for resiliency on the Outpost itself. So if we consider HA and DR, disaster recovery really requires and necessitates that you evaluate your recovery time objective and your recovery point objective, or RTO and RPO, to ensure that you're able to meet the requirements of the business. Now, if you're familiar, Chris, there's this concept of the AWS well-architected framework, which provides these different methodologies: backup and restore, pilot light, warm standby, or even something such as a multi-site active-active deployment. And these principles, while they're not specific to Outpost, can certainly be applied to Outpost when you have workloads residing there and in region. It's the same concepts that you would apply regardless. Now, built into an AWS Outpost, you of course have the ability to take EBS snapshots of the underlying volumes that reside there on premises. So you have a low latency need that must remain there on premises in your data center, but you don't necessarily have that data sovereignty or data residency challenge that some customers do. And if that's the case, you can simply leverage the built-in capabilities of streaming those snapshots up to region, which will allow a customer to quickly recover in the event that the outpost is no longer accessible, maybe due to the entire data center being unavailable. And so this can even be scripted and automated in ways such as using CloudFormation to take that snapshot and create AMIs and create new instances, or tools such as Terraform. For customers that maybe require that data residency or data sovereignty use case, customers can look to leveraging something like S3 locally on the outpost. And then those snapshots that would occur from the EBS volumes could reside there instead of having it leave the data center and reside back up in region. Now, you do have to consider the RTO and RPO as well. And if your recovery time objective necessitates the quickest spin up, a combination of the two of those might make perfect sense. And then I would say, lastly, there's a myriad of really good options surrounding data replication. Primarily at the block level and at the object level, but even above and beyond that, there are tools that exist from AWS to ensure that the entire infrastructure and all of the supporting systems can be replicated outside of a logical outpost. And maybe we should spend a moment talking about those.
Yeah, before you do that, I just want to highlight, Scott, a couple of things you called out that I think are awesome. So, you essentially have two choices. If you need that, high RPO, RTO requirements, where you say, hey, I really need to be able to recover very quickly. As Scott mentioned, I like that you can have the EBS snapshots stored locally on the Outpost. Probably not helping you in the event that you lose that Outpost, but certainly helping you if you lose an instance and need to recover it quickly or go back to a snapshot from a day ago or a week ago. I think that's awesome that with the local storage mechanisms, that you can get that back quickly. And then for the actual data protection, being able to replicate, your buckets, like your S3 on Outpost buckets, or being able to store, snapshots in the region. I think being able to do that and taking advantage of the higher data persistency and availability in the region is awesome. As we know, S3 in the region delivers 11 nines of availability. And I think it's fantastic that we can deploy our data on premises with the mechanisms we need there, as well as leveraging the persistence and availability of the region, as we may have need. So I think that's an awesome call out. So yeah, let's dive into DR, Scott. Let's take a look at what we can do to improve data protection.
I think I would consider first a fairly new feature that was rolled out just a few months ago on AWS Outposts, and that's support for Cloudinger. Now, customers may be familiar with Cloudinger. It actually has two main capabilities that are worth mentioning. The first is Cloudinger migrations, and this is where customers can target sources running on VMs or bare metal on premises. They can pick up those workloads using an agent, and they can streamline and easily migrate those workloads to the region. Now, this is designed to be a one-time move to enable quicker adoption and moving workloads into region. That same sort of model can be actually applied to on premises to pick up a workload and actually deploy that onto an outpost. And that outpost might reside in the same data center or a different one that the customer controls. Above and beyond Cloudinger migration, there's also Cloudinger disaster recovery. And that enhances migration a step further. And it actually means that you are able to do near real time, continuous block level replication from the source to the outpost. So this really creates a lot of interesting models. It could be between commodity hardware and an outpost, or it could even be between two outposts. Customers could actually leverage an outpost deployed into two completely separate distant sites and enable that communication path. Another option might be you have workloads deployed in region A and you have an outpost anchored to region B, and you would like to replicate that workload from region A to the outpost anchored to region B. Or lastly, to ensure that we have resiliency above and beyond the outpost and the data center, we could even replicate that infrastructure from an outpost up to a region. So we actually support quite a few different models as it pertains to Cloudinger, and the DR blog goes into a lot more details on how you might approach this. Now, secondly, we've mentioned data replication, and customers may be familiar with our AWS Data Sync. And this is an agent-based solution that allows traffic to move data from one source on premises and easily ingest it into targets in regions such as S3. Customers could also look to use data sync on an outpost to replicate from the outpost into region. And I think lastly, it's also worth considering how our partners have created different solutions that are available in the AWS marketplace. Oftentimes, these are agent-based solutions designed around backup and recovery and can even augment providing a single pane of glass for backups across their entire infrastructure. And so it's worth considering those options in the marketplace.
Yeah, so I like the patterns that we have here. So, for the data that lives on your outpost, or that you may be migrating to your outpost, you've got block level data, you've got object level data, and you've got services here that can help you replicate, using things like Cloudinger to replicate whole instances, perhaps running on the outpost to the region or to another outpost, as well as for data that's in your EBS volumes, that's in your S3 buckets. You can use data sync to sync your S3 buckets to the region. So I like the patterns that we have here for being able to use these mechanisms to protect the data that's stored on our premises, making sure that it is also stored someplace else, and being able to give us these options that customers have a lot of choice when it comes to moving data from on-prem to outposts, outpost to outposts, outpost to region, or even region to outpost. So love the patterns. So just wrapping up here, Scott, we've really just introduced these topics, I feel like we scratched a lot of surfaces here. And we've talked about, we introduced what an outpost was. We talked about some of the failure modes. And again, while not specific to Outposts, they're things that you need to consider as you're designing and architecting solutions to run on Outposts. We talked about how availability and security are shared responsibilities for customers that deploy Outposts, and how that shared responsibility model has been updated with some additional responsibilities for the customer as they deploy AWS Outposts infrastructure into their environments. And then we've gone over, like I said, just scratching the surface, but we've gone over some design considerations, some things that you need to think about as you plan to run your compute, your storage, your networking, workloads on your Outpost. And even just briefly touched on some large scale kind of event handling, or some of the mechanisms, I should say, that are available to help you protect and to implement disaster recovery strategies for whichever of those failure scenarios that you're planning for. So I know we're time constrained, and that we really just got to introduce these topics. Really want to make sure that you guys have the opportunity to dive into the details in the paper and in the blog post.
And it's worth mentioning, Chris, we don't really go into service specific considerations, things like our relational database service, or Elastic container service, or Elastic Kubernetes service, and the other available services that can run natively on an Outpost. The document will help to call out those things, but we've really focused on kind of the core infrastructure side in today's session. It's worth also calling out one last time the AWS Service Readiness Program. Now, this is a solution that we've put together specifically targeted at our marketplace partners that have solutions and stacks available there to ensure that they're able to validate their applications against an AWS Outpost. So as we mentioned earlier, that there's a myriad of different applications available in the marketplace, look for the AWS Service Readiness Program to ensure that they've been validated against an Outpost. And with that, I'd like to close out today by reminding everybody to be sure to check out the HA paper and Cloudinger DR blog post so that you can go further into the depth that they provide. And we really appreciate you joining today.